multiplication of vectors by a scalar. Objective: to study the multiplication of vectors with scalar quantities. When a vector is multiplied by a positive scalar quantity, its direction does not change. Only its length changes, proportional to the multiplicative factor. For example, consider a vector a bar of magnitude or length a. When it is multiplied by 2, the resulting vector is indicated with 2a bar. Magnitude of 2a bar is double that of a bar. Suppose if a bar is multiplied by 0.5, resulting vector's magnitude is half the magnitude of a bar. So, when a bar is multiplied by a scalar k, the magnitude of the resulting vector k a bar is k times of a bar. In case of k is 0, k a bar becomes null vector. If it is multiplied with a negative number, the resultant vector has a direction opposite to that of a bar and its magnitude is k times the magnitude of a bar. Suppose if the vector is multiplied by -1, the direction of the vector reverses, whereas its length remains the same. Let us look at subtraction of two vectors. Consider a bar and b bar. Let us subtract b bar from a bar. This can be written as a bar plus minus b bar. From our earlier discussion, minus b bar is a reverse vector of b bar. Now, we can add them using either triangle rule or parallelogram rule. The magnitude of a bar minus b bar is equal to root over a square plus b square minus 2ab cos theta, and the angle which the resultant makes with a bar is given by the expression tan theta equal to b sin theta by a minus b cos theta. If a vector is divided with its own magnitude, we get a vector with length 1 unit. Such a vector whose magnitude is 1 unit is called a unit vector. A cap over a symbol is used to indicate a unit vector. Summary: when a vector is multiplied by a positive number, direction of the vector does not change, only its length gets changed. When a vector is multiplied by a negative number, direction of the vector gets reversed.